Continuing on our 6.4 lesson, remember we are talking about completing the square. So, when we are given a trinomial, such as x squared plus bx plus c, that we can rewrite so that we can get it into that good old x plus m squared, we'd say that both polynomials are what we call perfect squares. And anytime that we're asked to write a polynomial as a perfect square, quote unquote, we want it in that x plus m squared form. So again, quick examples here. If we have x squared plus 2x plus 1, well, we can rewrite that expression as x plus 1 squared. And if you don't believe me, if we were to FOIL this out, our x plus 1 and x plus 1, x and x would be x squared. X and 1 is plus 1x. 1 and x is 1x, and 1 times 1 is 1. Combining these like terms, this becomes 2x. So we have x squared plus 2x plus 1, which is our original over here. Another one, let's go the other way. Let's say we wanted x plus 2 squared. Well, that would be the same as x plus 2, x plus 2. Foiling that out would give us x squared plus 2x plus 2x plus 4. Combining these like terms, 4x, so we would say x squared plus 4x plus 4 is another way to rewrite that expression. So both of these are considered those perfect squares. One more would be if we had x plus 3 squared. A way to rewrite that one, if we FOIL it out, would be x squared plus 6x plus 9. So these are just a couple of quick examples here. Now things that we want to notice here. Notice in each of these spots, this middle value, our b value from up here, if we take 2 divided by 2, that gives us this 1. 4 divided by 2, that's where we got the 2. 6 divided by 2 is our 3. So this middle value here, 2, 4, and 6, is just this value from over here doubled. Okay, so that's one thing to keep in mind. Another thing to be looking at is this value, 1, that's 1 squared. 4 is 2 squared. 9 is 3 squared. So notice how all of these work together, from the trinomial to the binomial squared. So these are all, like I said, examples of perfect squares, and we're going to want to use that when we're solving different equations here. I'll show you some examples. In this case, we have x squared plus 10x plus c, and we're asked to make it into a perfect square. So remember, we said x squared plus 10x plus something is what we're looking for. We need to find that c value. Well, remember, we said when we put it into a perfect square binomial, when we divide 10 by 2, that's going to give us this value. 10 over 2, or 10 divided by 2, is 5. So this would be the perfect square binomial that we're looking for. This c value in the end, the trinomial, remember that was 5 squared. We take this number and square it, so 5 squared equals 25. So when it's written like this, this is the perfect square trinomial that we're looking for. So in this case, we'd say c equals 25. And we got it by completing the square. So we're going to work through an example of how to solve by completing the square. So notice how, in this case, we aren't given a square, a perfect square. We are given x squared plus 6x minus 2 equals 0, which we can't quite factor down into a perfect square. But we can look at just this first part, the x squared and the 6x. Remember, you always just want to look at those first two values, x squared and 6x. And we need to make a perfect square out of that. So x squared plus 6x plus something should create a perfect square. And we remember that we do this value divided by 2 is what's going to give us this value. And 6 divided by 2 is 3. So this is our perfect square binomial when it's just written as the two values squared. Remember then, 3 squared equals 9. So that's the number we're looking for here. So we're trying to get it into that form. So what we do from there is we have our x squared plus 6x. Over here, we were looking for a 9. So we add 9 on the inside of this. So we took this part, the x squared plus 6, and added 9. We need to subtract 9 on the outside. So that's going to keep the whole value the same. When you add 9 and then subtract 9, it's like you didn't even change the whole equation. We still have the minus 2, and then that whole thing equals 0. So this is how we complete the square, or at least solve by completing the square. Now, from here, that's the same as x plus 3 squared, remember? So we literally just put it back into that form. Oops, not 3. X plus 3 squared. That was just that piece. We still have our minus 9 and our minus 2 on the outside, and the whole thing still equals 0. From here, we just combine some like terms, so we get x plus 3 squared minus 11 equals 0. And we just want to add 11 to both sides then. Get rid of this. Which leaves us with x plus 3 squared equals 11. So now we have it back in that form, x plus n squared equals m. So once we're here, we have our big M and our little n value. So we would say x equals square root of m minus n that we got from here. Now from here, we'd say our square root of n, our square root of 11, cannot be reduced anymore. So this is actually our final answer then, is the square root of 11 minus 3. Now again, if you wanted to check that, you would have to put this whole thing back into x. You can't just put the square root of 11 or the negative 3. You would have to plug in x equals negative 11 minus, or square root of 11 minus 3. That would go back into this original equation up here. So if we wanted to do that, that would look something like square root of 11 minus 3 squared plus 6 square root of 11 minus 3 minus 2 equals 0. Extend that. When we FOIL this piece out, because we have that squared, that's going to give us square root of 11 times square root of 11 is 11 minus 3 roots of 11 minus another 3 roots of 11, and minus 3 times minus, or negative 3 times negative 3 is positive 9. So this whole piece became this. This piece then becomes plus a 6 roots of 11 and minus 18. We still have our minus 2, and the whole thing still equals 0. When we combine these two, they become negative 6 roots of 11, which cancels out with our positive 6 roots of 11. Then we're left with 11, 9, negative 18, and negative 2, or minus 18 and minus 2. So if we combine these two, that's negative 20. Combine these two, that's a positive 20. Those will cancel out, and we're left with 0 equals 0, which is true. So our answer of x equals square root of 11 minus 3 is correct. So that's how you would work or solve by completing the square.